So there are multiple of the network. If I will talk about the type of the addresses, okay, address types. There are a lot of address type in case of your IPv4, and same thing. There can be lot of type into your IPv6. One of the type can be the private and public. Remember?
Yeah.
There can be class A, there can be class B address, C address, D address, bit like that, right?
Yeah.
Here you can have something named as unicast.
Yeah. Yeah.
Majorly, if I'm talking about, you can have multicast, and there is one more thing. There is named as anycast. Please do remember, there is no broadcast here. Broadcast is not there available in the IPv6. Getting my point?
Yeah.
So generally, if I will talk about one-on-one mapping, if you talk about one-on-one mapping, that is your anycast. Multicast is one-to-many. So when you need to do one-to-many mapping, it is your multicast. And this is named as one-to-closest. One-to-closest. That is your anycast. Let me give you an example of the anycast. Let us say you are using Netflix. Okay. Netflix is in the US also. It's in the Europe, Africa, okay, maybe Australia, maybe your APAC region. Okay. So if you are from the APAC region, you will go to the Netflix server which is nearest to the APAC, not in the US. But US people will go to the US. It might be they are using same IP, but user will go to the closest. Are you getting my point?
Yeah.
So anycast is one to the closest, whatever the closest information it will. But that is again a long things. I cannot discuss those things. I need to talk about some more stuff over here, which is named as link local. Very important, link local address. In IPv6, okay, in IPv6, whenever you put any interface, any router interface, and you assign any IPv6 IP over, okay, automatically it will generate an address named as link local. And this address is really very important because all of the control plane communications, bit like your OSPF, EIGRP, hello, or whatever hellos, okay, all those
Yeah.
information will go through the link local. Getting my point?
Yes.
It will start like this, FE80, okay, and it can go like anyway because the network bits is equal to 10. So first 10 bits are reserved, as I told you. Next, bits will be get derived from your interface ID, from your MAC. Whatever your MAC interface is, it will use that. Okay. So first digit is FE80. Rest will be 0000000. Right? Then
Yes.
your MAC is there. It will use your MAC ID, and in between your MAC, it will insert 2 zeros because your MAC is 48 bits. It need to make it as 64 bits. So it will just add 16 bits more. Getting my point?
Yes.
So that is how it will configure the link local. And if you see, even let me open the command prompt. Give me a minute. You can open your mobile also, but I am just opening my PC. If I will show you IP config, can you see this FE80? Right?
Yeah.
So link local address is even there as well in my PC, in my Microsoft PC. Getting my point?
Yeah.
Same way, you will be having this on the different devices as well when you enable the IPv6. So this point is clear.
Yeah, it's okay.
Then you can have multicast address. So you can have multicast addressing in IP version 6. So this multicast addressing, the first bits will be like this, FF. Okay, 0,
Yeah.
2. So this FF, or it's ideally FF00//8. This is fixed for your multicast. Okay, bit like in your uh, IPv4, this is how you can use, right? Similarly,
Yeah.
in IPv6, you can use like this. Getting my point?
Yes, yes.
If I'm not wrong, it's /8 or /12, bit like that. Okay.
Yeah.
So what happened is, like if you are using FF02 and 1, this is for all nodes multicasted. Similarly, FF02, then 2, it is for all routers. Then FF02 and then 5, it is for OSPF. Then bit like FF02 and 6, it is for your DRBDR. Getting my point? The
Yeah.
same 224005 and 224006. Bit like, okay. So this is how it will use. Then you can have loopback also over there, and you can have something named as unique local. Okay, unique local
Yeah.
bit like your private IP address, private IP, private IPv4 equivalent to your unique local. Okay, so
Yeah.
this unique local is again well structured. Can start from FC00/7. Okay, so if you have FC kind of stuff, it means it is bit like your unique local or the private IP. Similarly, you can have global local, which is bit equivalent to your public IPv4, right? Routable IPs.
Yeah.
It is global. So this can start from your like any value, maybe 2000//3. Okay.
Yeah.
If you are using anything using 2, starting with 2, maybe you can just go with IANA, maybe distribute it to different things. I hope you are aware that in case of Cisco, there is CDP neighbor command which will find out whatever my CDP neighbors are, right?
Yeah.
Here is NDP. NDP is bit equivalent to R. Okay, why I use CDP? Because just to relate it. Okay, there is NDP.
Yeah.
NDP bit like to R. What is the use of R? IP to the MAC resolution. Similarly, IPv6 to MAC will be gonna done by your NDP protocol named as Neighbor Discovery Protocol. Any question?
No, it's okay.
So when we are, let me just jump on the OSPF version 3 then. When we are using OSPF version 3, all the things are same. Bit like I talked about LSA 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 9. Okay. So same thing are there also, right? If you talk about router ID, here one interesting fact is it will pick the router ID as IPv4. Hello packets, same way, right? Neighbor discovery, same way. DRBDR, same. Network type, stub, NSSA, totally stub, same. Okay. SPT, same. Virtual link, same. Everything is same. Concepts are literally same with your OSPF version 2, which is running on IPv4. OSPF version 3 is for your IP version 6. Getting my point?
Yeah.
So these are same with some little difference. Difference is your LSCs. Okay. Here the LSA code, LSA you can say name, and LSA number will be different little bit, right?
Yeah.
Earlier you were using LSA1, which is named as router LSA, right? I'm just
Yes.
giving you an example. Here it is hexadecimal, so it is representing by 0x. The number will be 2001 and the name will be router LSA. Okay, so bit like that.
Yeah.
Number will get changed. And two more LSA will come into the picture over here, which is 0x, if I'm not wrong, 0008, which is named as link LSA, and intra-area prefix LSA. So those some LSA will get introduced, but you need not to go under such a deep dive. That's fine. Okay, these are the things which are used. But you need to understand one thing, as I told you, that if you are enabling the OSPF version 3 on the device, okay, the hello will be go using the link local. Using the link local.
Yeah.
Getting my point?
Yes. Yes.
And earlier I asked this question during our, OSPF class that if I have two routers running OSPF, there is a primary IP, there are some secondary IP, there is primary IP, there are some secondary IP. And I gave you an example that the OSPF will come up only on the primary IP, not on the secondary.
Yeah.
So same wise here, there can be multiple IPs configured on the interfaces. But OSPF will come up only using the link local. Is this point clear?
Yeah.
Fine. Let me maybe create a lab for you and so that I can show you the same thing in the lab.
Okay.
Let me stop everything because the rest things are same. Either we are doing it on the two routers or on the multiple routers, hardly matter. Let me maybe just bring up. Okay. So I have two routers, router 4 and router 5. Let me just go to the router 4, conf terminal. Here if you see interface gig 0 by 1. Interface gig 0 by 1. Let me say IPv6 address and I can put any address, maybe 2024 is working year. So let me just say like this. Okay. I just put address. So this is a public IP, if you can see over there, which I assigned on the interface gig 0 by 1. Let me show you now. Show IP version 6 interface. Which interface it is this? Gig 0 by 1. Can you see automatically link local come into the picture?
Yeah.
What is the global IP? This is the global unicast. Can you see that?
Yeah.
So that is how you can create a IPv6, right?
Yes.
If I will show you same show IPv6 interface brief, you can able to see here, you can able to see a link local and you can see a global, right?
Yeah.
I will show you show interface. Can you see the MAC address? This is the MAC address of your
Yeah.
burnt-in MAC address. Okay. And if you will try to
Yes.
see over here, these MAC address, these bits which you can see over here are getting derived from this MAC address. Gig 0 by 1, not this. Gig 0 by 1. Okay.
Yeah.
Uh, Let me maybe copy this on a notepad. And let me copy this link local also. on the notepad. So you can see 8C01, 8C01, right? So that is how, like, all of these bits are getting derived from your map. Getting my point?
Yes.
Okay. Fine. Now let me enable this IPv6 on the router 5 also. Let me go on to the router 5. Interface gig 0 by 1, IPv6 address 2024 colon, this side 5 maybe, and this is 64. Okay. And
Yeah.
let me make it no shut. Interface gig 0 by 1, no shut. So IPv6 interface gig 0 by 1. You can see link local generated automatically. Okay. And you can see global unicast address, right? Can you see process ID? It is showing, and it is showing that it is up. That is a ELF, the IPv2. Okay. That will break that.
Yeah.
Let me make it as no. Or leave it. Leave it. We can generate the OSPF version 3 in a moment. So to generate the OSPF version 3, what you need to do, you need to understand, first you need to enable the IPv6 globally. So you need to go into the config terminal command, and here you can see IP version 6 with the command unicast routing. Getting my point?
Yes.
Then you need to say which, this is one thing. Then you need to talk about IPv6, which router OSPF you want it to run, maybe 45, 55, whatever, like this. I'm just using a common, okay, so that I can copy this from the notepad to the device. And you need to go into the interface. And on the interface, you need to enable this OSPF, like IPv6 OSPF. OSPF is 45. What is area? Maybe can you use the area for? Are you getting my point? These commands
Yeah.
are clear to you? And
Yeah.
then maybe you can go to the end and you can just do that. Let me just copy these commands and put it over here on the R5. Okay. And let me go on to the R4. Do the same over here on the R4. In a moment, you will see that one more neighborship will come into the picture. And that will be IPv6 neighborship. Getting my point?
Yeah.
I will show IPv6 OSPF neighbor. Okay. Currently it is under the 2. Can you see?
Yeah.
Router ID, can you see? It's an IPv4, right? So
Yeah.
it is just under the two-way. You are aware about why in the two-way it is taking a long time, because it is selecting the DR, BDR, and post that it will go into the further states. Okay.
Yes.
Extract, exchange, loading, and full. So just wait for a while. You can see it's a full now. Can you see that?
Yeah.
If you go to the router 5 now, you can see that it is showing you full, right? And this is
Yeah.
process ID 45, which we did for the OSPF version 3. You can see it's an OSPF version 3, right?
Yeah.
But if I will check show IPv6 route, is there any route coming? No route is coming. Why?
No.
Because there is no route we advertise. Let us advertise a route. I'm going on to the config terminal, going into the interface loopback, maybe 11. Okay. Here, I can just enable a IPv6 address and maybe some private range FD01 colon, or maybe let me take one more 2024 and then 11 slash 64 maybe. Okay. And then I need to put it under the OSPF. How I can do that? IPv6. Now there is no network command. Please do note it. 45 and area is also 45. Under the OSPF interface, I am enabling the OSPF. Are you getting my point?
Yeah.
But so on the router 5, if I will show you, can you see one route is coming using the OSPF? The same route which we created before a while, which is FD01, 2024 and 11. One very, very important point. The next hop will be your link local address only. Is this point is clear?
Yeah.
Okay, one thing last which I need to discuss. It will take hardly 2 minutes, and post that we will wrap it up. Okay.
Yeah, it's okay.
So,
Yeah.
if one thing is, if you will see show IP OSPF neighbor, there is a separate OSPF process which I am configuring. And if you will see show ipv6 OSPF neighbor, there is a separate process ID which I am configuring, right? So if you see
Yes.
show and section router OSPF, there is two time I am configuring it. One is ipv6 and one is for ipv4, right? If I don't need to do that, I want a single solution for which can run ipv6 and ipv4. Is there any way? Yes, there is a way. That is named as dual stack. That is the last point, okay, for today's class. Let me just show you quickly. I am going over here, making it as no. Okay. Similarly, making it as also as no. Okay. IPv6 and IPv4, I am breaking. Similarly, on router 4, show run section router OSPF. I will go to the config terminal. Here, I am saying this as no. Similarly, I am showing this as well as no. Okay, so both are the tests.
Yeah.
I have removed all of those stuff. Now what I need to do? I need to create something named as dual stack. How can I do? I will go to the config terminal. I will say router OSPF, okay, version 3, and post that you can use some process ID. Let me use process ID like 100, right? Here it is saying, I can say address family can be IPv4 unicast and address family can be IPv6 unicast. That's it. Getting my point?
Yeah.
Let's go to the interface like gig 0/1 in our case. We will say OSPF version 3. Which version is 100? What is the process ID? 100. Okay. I can say IPv4 area. Maybe I am just using area as 45 for IPv4. And similarly, for IPv6, let me use area. I am just reversing it 54. Getting my point?
Yeah.
Let me use the same on loopback 11 also, the same thing. Okay. Let me go back to the router 5. In the router 5, I can put the same command on T router OSPF version 3, and maybe let me just take 100 only over there. Then address family IPv4 unicast, and similarly v6 as a unicast. Exit, and then let me go to the gig interface 0/1 where I am running both of the areas. OSPF version 3, 100, IPv4 area is 45. See, it is up. And here for IPv6 area is 54. Getting my point?
Yeah.
And can you see both are up? Both are up.
Yep.
So check IP OSPF version 3. Sorry, it should be show OSPF version neighbor. Can you see both neighborship are up?
Yeah.
Both neighborship is with 55555. One is with IPv4, one is with IPv6. Any question, please ask.
That's okay.
So IP route, if you see, there is nothing. So IPv6 route, if you see, there should be one with the OSPF. Any question, please ask.
No, it's okay.
Fine. Then we have concluded our OSPF today. Okay.
Yeah.
Most probably we will take one day off tomorrow and we will meet on Tuesday. Okay.
Yeah, sure. Yes, yes, sure.
Till then, please go through all of the classes. If you have any doubt, ask me, call me, drop a message, drop an email.
Yeah.
I will happy to help you out.
Thank
Okay.
you. Thank you so much.
So
Yeah.
if there is anything, you can ask. Otherwise, we are good to wrap it up.
Yeah, yeah. Thank you.
Okay. Thank you. Have a great day. Take care of yourself and your family. Bye.
Okay.